Continuing in 12.3, we're up to example 5. And this time they want us to find the points of intersection of the circle r equals 3 cosine theta and r equals 1 plus the cosine of theta, which means I'm going to set these equal to each other. And when I try to solve it, I'm going to have 2 the cosine of theta equals 1. When does the cosine of theta equal a half? Well, it equals a half here and here with a reference angle of pi over 3. So plus and minus pi over 3 are your thetas. Now, they want to know the actual intersection points. All I know is theta. I've got to go back and get r. So if I go back, I've got to plug pi over 3 in. R would equal to 3 times the cosine of pi over 3. So that's going to give me 3 times 1/2 or 3/2. So one point is r comma theta, 3/2 comma pi over 3. The other one, sticking in the negative pi over 3, you still get 3/2. And so the other point is 3/2 comma negative pi over 3. Now, we need to look at the graph. If I graphed this, the circle 3 cosine theta, when you graph it on a graphing calculator, it's going to be on the positive x-axis when you draw it, when you draw the problem out. So let's see if I can find one that looks good. Maybe here. And this would be 3. The cardioid is the same one from before, and we know it crosses at 2. So it's going out like this, coming around, hitting 2, coming back around and heading in. A little sloppy, but there you go. So this spot right here is your pi over 3, and this spot over here is your pi over, negative pi over 3. So you see there is actually a third spot that they have in common. But the question here is, when does that happen? So if you are graphing, if we look at the cardioid, as you plot points for the cardioid, you will notice that when you get to pi, from 0 to pi over 2, when you plug in pi, that's when you get 0. So for the cardioid, it's happening at pi. The circle passes through it at pi over 2. And again, you get that by starting to plug numbers into your circle. And as you plug in numbers, when you get to pi over 2, you end up getting 0. Which means if I check this, if I take my answer of pi for the cardioid and I plug it into the circle equation, I get negative 3. I don't get 0. And likewise, if I take the pi over 2 that is sitting for the 0 on the circle and plug it into the cardioid, I get 1. So even though it looks like it crosses there, they cross at that pole at different times. So it's not an intersection point. So you have to be very careful of that. Now we're going to look at number 6. In example 5, same picture. Use the results to compute the areas of part A is the region in A, and A is marked up there now. And then part B wants us to find the region in B, which is the top half of this, and then C, which is that piece right there. So I've marked them up there, but I'm going to take them apart little piece at a time. So a very quick sketch of this. We have a circle that's out here. We have a cardioid that comes around, excuse me, crosses, comes around. The first section they want is this. So we know that intersection point, that point is happening at pi over 3. So starting at 0, going to pi over 3. So we have 1/2 the integral from 0 to pi over 3. And the function that I'm using in this case, well, this is a double. It's got the circle on the outside, it's got the cardioid on the inside. So the circle is going to be squared minus the cardioid is going to be squared. And I'm going to do like they did and cheat my way through the squaring process. So I have 0 to pi over 3. This turns into 9 cosine squared of theta minus 1 minus 2 cosine theta minus cosine squared of theta, d theta. 1/2 0 to pi over 3. That's going to be 8 cosine squared of theta minus 1 minus 2 cosine theta, collecting my like terms. If I change the cosine squared to 1 plus cosine 2 theta over 2 and simplify all this stuff, you will get a 3 plus 4 the cosine of 2 theta minus the 2 cosine theta. So we've combined the negative 1 that's in the middle up there with what happens when you replace the cosine squared. So integrating it, 1/2 3 theta. This is going to be, cosine turns into sine with a 1/2 in front, so 2. This one's going to be 2 sine. Oops, different sides. Okay, and then 0 to pi over 3. And then I think at that point you should be able to do that. The answer is pi over 2 when you plug and chug. Part B, same picture. I'm getting sloppier with my pictures. Only this time they're wanting B, which is all of this. So now, if we look at that one, we've got to split this up. Because, and I wish I could use different colors here, I've tried to draw this line in really, really big. Okay. I've got a really thick line I drew there. You have 2 pieces for this one. You're going to have to work out 1/2 the integral from 0 to pi over 3 of the cardioid to get the portion. I'm going to draw it again. Oh, that was not good at all. Circle's in the wrong place. To get just this piece and leaving out that little sliver. So we're going to have to do the 1 plus the cosine of theta, quantity squared, d theta, and then we're going to have to add to it the part that goes from pi over 3, where they intersected, to pi over 2, where the circle hits the pole, and integrate the circle squared. And then when you get done doing that piece, they say, and I'm going to do the same thing because we'll just keep redoing the same problems over and over and over again. And we could crank that all out and get an answer, but it might actually be easier to notice that the area of region B is actually equal to the semicircle, half the circle, minus region A. You look at it again, it's a half a circle minus region A. So we could do it that way as well and get it in one step. Since a half a circle the half circle, this particular circle is a circle with a radius. Its diameter is 3, so its radius is 3/2. So its area is going to be 1/2 pi the radius squared minus the answer in part A was pi over 2. And when you simplify that, you get 5 pi over 8. So you can crank out the integrals as I set them up, or you can notice that part A is the piece that's missing from the half circle to get part B. Part C wants us, and I'm going to draw another picture. Let's see if I can draw my circle in the right place this time. That's a pretty sad circle. And it comes around like this. Okay, this time they want the little piece that is outside the circle but inside the cardioid, just this chunk up here. Now you've got to be careful with this. When I draw in a ray from the origin out, you can see that yes, the circle is inside and the cardioid is outside. But if I draw it to the left side of the cardioid, out here, you will notice that only the cardioid is used in that portion of it. It's not the circle. So if I can draw a better picture here, let me draw just that piece so you can see what's happening, maybe. Okay, if I look at just that, and then I have my circle coming through, you can see that we could stop it. We have two sections to work with here. We have a section, this section, that is just the cardioid. And then we have this, how am I going to mark it? This section is just the cardioid. And then this section is the cardioid minus the circle. So I'm going to put the hash marks a different direction. So I've got to set this up as two pieces. Let's do the cardioid minus the circle first. So we're going to have 1/2 the integral. Now that intersection point was at pi over 3. So we're still going to go to from pi over 3. But we're going to stop it right there at pi over 2. Where I put the dot. And so now I have the cardioid is on the outside, so 1 plus the cardioid cosine squared minus then the circle 3 cosine theta quantity squared d theta, and then I need to add to that from pi over 2 till I get to pi, because pi is when the cardioid hits the circle. Remember way back at the beginning in example 5. Pi is where the cardioid hits, not the circle, hits the origin, the pole. So this spot right here is at pi on the cardioid. So I'm going to go from pi over 2 to pi. This is 1 plus cosine theta quantity squared d theta. Now after you do all the simplifying and changing using the half angle identity and integrating, you will get the answer pi over 8. And you should be able to crank the rest of that out yourself. The hardest part about these is figuring out what section you're looking at and which curve is making that section. This concludes 12.3 and the last section of the course.